Fundamentals of calculus, the mathematical study of continuous change. At its core, calculus deals with functions like this quadratic function, f of x equals x squared. Calculus has two main branches, differential calculus and integral calculus. Differential calculus focuses on rates of change. The derivative represents the instantaneous slope of a function at any point. For our function f of x equals x squared, let's see how the derivative works. As we move along the curve, the slope changes. The derivative f prime of x equals 2x gives us the exact slope at any point. Now let's explore integral calculus, which finds the accumulation of quantities and areas under curves. For the function f of x equals 2x, we can find the area under the curve by integrating. As we use more rectangles to approximate the area, we get closer to the exact value. The fundamental theorem of calculus connects derivatives and integrals as inverse operations. If we start with f of x equals x squared and differentiate, we get f prime of x equals 2x. Conversely, if we integrate f prime of x equals 2x, we get back to our original function f of x equals x squared plus a constant. This is the essence of the fundamental theorem of calculus. Derivatives and integrals are inverse operations. These fundamental concepts of calculus form the basis for solving a wide range of real-world problems. Calculus powers many aspects of our modern world. Let's explore how calculus is applied in different fields. In physics, derivatives calculate velocity and acceleration from position functions. The derivative of position gives us velocity. For this position function, the velocity is 2t minus 3. The derivative of velocity gives us acceleration, which in this case is a constant 2, while integrals determine displacement from velocity, allowing us to recover the original position function. In economics, marginal cost and revenue are applications of derivatives that help businesses optimize profits. The profit function is the difference between revenue and cost. To optimize profit, we find where the derivative equals 0. Taking the derivative of the profit function, we get p prime of x equals 80 minus 4x. Setting this equal to 0 and solving, we find that the optimal quantity is 20 units. The maximum profit point actually falls outside our current view at x equals 20, where the profit would be maximum. In engineering, calculus helps design bridges by calculating stress distributions and determining minimum material requirements. Using calculus, engineers can calculate how stress is distributed across a bridge. The integral of the stress function over the length of the bridge gives the total load it can support. In medicine, calculus models how drugs disperse through the bloodstream over time. This graph shows how a drug's concentration in the bloodstream changes over time. Taking the derivative and setting it equal to 0 helps determine when the drug reaches its peak concentration. For this model, the maximum concentration occurs at 4 hours after administration.